Hello and welcome to the 20-minute Lightning Wallet workshop. This is literally and figuratively a Lightning workshop because we are going to go as fast as we can, and we're going to try and build a Lightning wallet here in 20 minutes. And so every year, every few months, in fact, it gets easier and easier and more convenient to build on Lightning. The tooling, the processes, the libraries are getting better and better. And so I'm able to keep giving easier and shorter Lightning workshops for helping new developers get started building on Lightning. And so this is now the pinnacle, I believe, my ideal setup, what I use for development all throughout the week for Lightning. And that is powered by Voltage and MutinyNet. Voltage being the infrastructure, and then MutinyNet being the test network that we're going to be doing all of our Lightning stuff on. So I think we're going to be able to do this in about 20 minutes. I think it'll be pretty easy and convenient, and we're just going to build the most bare bones simple wallet that you can take and run with, build off of, learn with. So yeah, let's get into it. Let's get started. So first of all, links up front. You've got links to these slides, which have the code as well as some explanations that I'm going to walk through. You can find that at this tiny URL, 20-minute Lightning link. We've got the completed project on GitHub. That is the 20-minute Lightning workshop. And then we have documentation here for MutinyNet Dev Sandbox, which can be useful, but I should be going over everything that you need to find. Okay, and so this is the overview of what we're going to be going through. Developing on Bitcoin and Lightning, difficulties of developing on Bitcoin and Lightning. We're going to be talking about the different Bitcoin networks, and then that's going to lead into an intro for MutinyNet, the SIGNet that we'll be using, and just my favorite way to develop on Bitcoin and Lightning. And then we've got free development nodes on Voltage. We're going to spin up a development node, or I'll show you how, and then we'll build our simple wallet application. So this should be pretty straightforward. Let's get started with some high-level ideas here. So developing on Bitcoin and Lightning, there's a lot you could say about the process, but very high level, here's some of the things you need to know and some of the things you need to deal with. So basic knowledge of the protocol, right? Bitcoin and Lightning protocol, the understanding of Bitcoin and Lightning node infrastructure, right? Because if you're building on Bitcoin and Lightning, the thing that you're talking to, the thing that you're interfacing with is a node. So you kind of got to deal with that infrastructure. And part of that is going to be knowledge about the networking, and the P2P networks, and just interfacing with it, and maybe interfacing with different nodes talking to each other even, especially in the case of Lightning. Understanding of Bitcoin's various test networks, which of course we're going to get into. And then understanding of RPC, gRPC, and ZMQ interfaces, right? These are the different programmatic interfaces that you might plug into. For our workshop here, we're just going to be using the regular REST HTTP interface, which I think is the most simple, but it's a little more abstracted than these other interfaces that you might use eventually to make things faster and more efficient. And then for Lightning, understanding the different node implementations and their trade-offs. There's core Lightning, there's LND, which is mostly what I use. You've got Eclair, you've got LDK. So there's different options for building on Lightning, but I think sticking with LND is a good place to start as a beginner. Okay, so those are some high-level, kind of, I guess, requirements, some things you need to know. But there's a lot of pain behind this. This makes for a barrier to entry for building on Lightning, right? And here's some of those points, that really add to that. Spinning up a node for development can be hard. Running SIGNet, testnet, regtest on a node can be hard. It can take a while to set up. It's not readily available information. This stops a lot of people right from step 0 of trying to build on Bitcoin. Interfacing with your node, learning those interfaces and how to talk through them can be difficult. Testing payments and interactions between wallets, between nodes. How do you set that up, right? What is the environment? And then, of course, testing development nodes, features across time is hard. Maybe I set up this environment to test for a few minutes, but then if I have this long living wallet or long living app, maybe I want to test it across weeks. So it's very difficult to set up. But of course, Voltage and MutinyNet helps with all of these issues. But first, let's talk about the different Bitcoin networks. This is important. So the different Bitcoin networks, you have mainnet. Obviously, this is the real main Bitcoin that we know and love. This is the valuable Bitcoin. Sometimes we develop on mainnet. Ideally, you don't have to, but sometimes it's just easier to develop on mainnet. Testnet is the OG test network for Bitcoin. And testnet is global. It's a global network. It works just like Bitcoin. And you even mine on it. But of course, the Bitcoins on it are testnet. They're just not valuable. People just decide not to treat them as valuable, so there's less hash rate and everything. But besides that, it's a perfect clone of the Bitcoin mainnet. And so it's been like the most popular traditional way of people testing. You then have reg test or regression test mode. This is a local fake Bitcoin network that you spin up on your machine. So this is nice in so many ways. If you don't need to interface with the rest of the world, you can spin up from block zero, a Bitcoin network on your machine and work within that network to develop your app. So we've used regtest a lot. I've used regtest in courses and workshops and stuff like that. So you may be familiar with that. And then finally, we have Signet, a relatively newer network that is like testnet, but with a twist. Signet is a test network that uses signed blocks, which means it has more reliable block times compared to testnet. So Signet is just like testnet. It's global, it's fake, but it doesn't mimic mining. It doesn't have real proof of work mining. Instead, at some interval, blocks are just signed and then they're valid, right? So there's an authority there that validates blocks for you. Which is fine for testing because we're not, developing real adversarial apps. So in a lot of ways, Signet, it kind of strikes the best trade-off between all of the options, depending on what you're doing. But okay, that's a lot of words. Let me summarize this for you. In short, mainnet is global and real. Testnet is global and fake. And then regtest is local only and fake, right? It's just this local only network. And Signet, like testnet, is also global and fake. So that's kind of a simple way you can think of it. Maybe you would tag on to testnet, global and fake, but has real mining. And then on Signet, you would say global and fake, but has signed blocks, right? So those are kind of the differences. Okay, and then enter MutinyNet. MutinyNet is everyone's new and favorite beloved Bitcoin Signet, and it's now on Voltage. And so MutinyNet is a Signet made by the Mutiny team, Mutiny Wallet team. And Mutiny Wallet isn't even around anymore. They've sunsetted it, but MutinyNet has been so valuable and useful that it is still running. It is still being used by people, and there's great tooling around it. And so why MutinyNet? This is from their original blog post. You've just got simplified testing infrastructure, a simple test network meant for developers that has a consistent, faster block times, right? So the default Signet block time, because there's a main Bitcoin Signet, is 10 minutes, but on MutinyNet, it is down to 30 seconds. So you have way faster confirmation times. You can keep the testing going very quickly. And of course, testing over time, like we talked about. This is a long living network. So you spin up a MutinyNet node, you build an app. You can have that deployed and running for weeks and maybe find issues that you wouldn't have been able to find in your small 30-minute test. So that's another thing. And then, of course, custom signets are cool. You can actually build your own signet on Bitcoin. Anyone can, which is kind of cool. And this just happens to be the convenient one that a lot of us developers have centered around. Great. And so MutinyNet on Voltage is completely free. So that means with a free account, you get one free MutinyNet Lightning node or one free MutinyNet Bitcoin node. And you can sign up with just an email. So no credit card, no KYC required. You can get a free development node to start with, the the ultimate platform for developing on Bitcoin and Lightning, in my opinion. And having one node is about all you need, because you can build all manner of apps on that one node. I'll tell you that. And so, yeah, when you go to create a new node, you'll see this MutinyNet free option, and you can just spin up a free MutinyNet and in just a matter of 30 seconds or a minute. And then there's some useful MutinyNet tools here that we'll open up and get into. I'm going to walk you through this MutinyNet on, here we go. Walk through how to spin up MutinyNet nodes. You can go to app.voltage.cloud, create a free account with email and password, go to Lightning Nodes, new node, and select MutinyNet. So let me actually just show you what that looks like. I'm already signed in here. So if you're signed in, you can go to infrastructure. This is my team. I've got Lightning nodes, and I can do new node. And then I see the MutinyNet option right here, which says free. I can click continue, give my node a name, and then you would need to give it a password. And this password's important because it's what will encrypt your node. So be sure not to lose it. But after that, you would just hit create. It would take about, a minute to 5 minutes to spin up the node. And then once it is spun up, you will see something like this. This is one of my MutinyNet nodes here that is running and that I use all of the time. And so this is the node dashboard that you'll be dropped into, and you'll have this full, beautiful platform with all of these tools, all this information, configuration, which will just be a great launch pad for you for developing on Lightning. So that is how you spin up a node. Useful MutinyNet tools. Let's actually open these up. So you've got the faucet.mutinynet.com. This is a great way to get payments, channels, on-chain, everything you need, because, it's all fake Bitcoin, right? So we can have faucets for it. There's also a faucet actually built right into Voltage for MutinyNet here, which makes it even more convenient. We have a block explorer for MutinyNet. So this is a fork of mempool.space, or really a custom instance of mempool.space just for MutinyNet. And so we can see all of the 30-second blocks here just now, 1 minute ago, 2 minutes ago, 2 minutes ago. So we see those 30-second blocks, and we can even, I can find probably my Lightning node here somewhere, PlebDevs test. There it is. And here we go. They've got my Lightning node actually on the network. We see all my channels, most of them with the MutinyNet faucet. But yeah, so that works as a block explorer. And then finally, they have a Lightning address right here. I'll open this up in a new tab, drag it to the end. So this is a way to get invoices that you can pay, which is important for our testing. And so you'll go to this URL, and I know this looks weird. This is just the Lightning address format. You'll have this callback URL, and you'll open up the callback URL, and you'll add at the very end of it, you'll add $amount equals some number, and that number will be millisats. So if I want to make a 21 sat invoice, I'll do 21,000, hit enter, and then here we go. It gives me a 21,000 sat invoice. Great, so those are our MutinyNet tools. And then we've spun up our MutinyNet node. Great, okay, so now we have our environment set up. We have a MutinyNet node ready to go. We have our tools open and ready to go. So let's get into the wallet demo and get through this wallet as quickly as possible. Trying to keep it at 20 minutes, so let's go. The very first thing we're gonna do here is create a new Vite React app. So this simple wallet app is gonna be made with React. You can either do this locally or you can do it on Replit. Replit makes it super easy to just spin up one of these React JavaScript templates and it will work perfectly. But I'm gonna go ahead and do mine locally. So I'm gonna copy this command and we're gonna start to make a new code base here locally. So I'll open up the terminal. Let's actually give me one. Okay, so I'll go to my desktop and we'll just paste this command. Px create Vite at latest, MutinyNet workshop template React. Okay, and then I'll cd into here, it's been created, and I'll open it up in my cursor IDE. Okay, beautiful. And then we're gonna have some install commands here, and then some environment variables to put in. So let's copy this install command first of all, and we'll go to our new code base right here. I'll open up the terminal, We'll zoom in a little bit. And I'll paste this command to install Axios. This is the one library that we'll need for doing API calls. And then next, we'll need to create environment variables, like it says here. These are going to be for our secrets, one of them being the macaroon, which is our permission token to talk to our node, and the other is our host, which is where our node actually is. So I can copy these two values and create a new .env file at the root, and I'll paste these in, and then we'll just put in our real values here in a second. Okay, let's do npm run dev now and look at our starter app here. Localhost 5173. Beautiful. Okay, so it all renders, seems to work, just a sanity check. Okay, now let's grab our environment variables from our Voltage node here. So the first one I'm going to need for my host is API endpoint right here. So I'll copy that and I'll put it in as the host equals PlebDevs test. And then for the macaroon, you'll go to the left sidebar here, manage access, macaroon bakery. We've got our default admin macaroon is what we want. And I'll click copy hex. Oh, and you'll need to unlock your node for this. Copy the hex, and then we'll paste it in right here. Okay, great. Now let's start to build out this code. We're going to do this quick and aggressive to try and stick to our timeline. But the code is very simple and structured in a very, very simple way. So we'll start out by updating app.js, and we're going to show some fake info at first here. So we have a basic app here, we have an info state, and we have this fetch info function, which is setting this hard-coded fake info of an alias for a node alias and an identity pub key. So this is fake info. We run a use effect when the app renders, and then we simply show that info. So with that saved, I should be able to go back to localhost, 5173, and we see connected Alice with our pub key. Awesome. Okay, so our first bit of code in. Next, we're going to create a interface for LND. So we're going to create a new folder, lib, and a new file, lnd.js, for housing our API calls. And so I'll copy this, and then we'll walk through this code. So new folder, lib, new file, lnd.js. We'll paste this in. Okay, so what's happening here is we're pulling in the Axios library for requests. We are pulling in our two environment variables. Should be correct, vite lnd host, yep. And then we are creating a new Axios instance, which is pointing at our host at 8080, which is the correct port for talking through the REST interface. Let me zoom in a little more here for you all. And then we are setting aside this header, gRPC metadata macaroon, which is how you bring your macaroon to authenticate with your own node. So there we go. That's our LND instance. And with this, we can make a new general function called getInfo that just does lnd.get at the correct getInfo API endpoint. And then we just return that data or catch any error. And so all of our LND methods will have basically this structure. And just to dig a little bit deeper, if we go LND API, if you search that, you'll find the LND API docs. You can go into Lightning service and find getInfo. And you'll see here full documentation. Let's turn this to dark mode. Full documentation of the getInfo endpoint with code examples, with documentation describing every single parameter. So this is where you can dig deeper after this workshop, right? We're going to be using these very basic LND endpoints, but they have all sorts of functionality in them that you can dig into and explore and expand your app and learn a lot more. So just so you know what's going on under the surface. But okay, we have this LND getInfo function now created. So let's go back to the slides, and we'll now want to bring this into our app.jsx to render the real info. So let's copy this over into app.jsx, and we can just paste over the whole thing for right now. Okay, and now we're importing get info from liblnd, and we are calling that actual get info function. We're setting the state just like before, and then we should be displaying it. So let's go ahead and make sure our real info is being displayed. There we go. Connected to PlebDevs test. That's my node's alias. And then here's our pub key. So that works. So we're talking to our Lightning node for real. Let's go. Let's continue on. Next, we're going to add a method for fetching balances so we can see our Lightning node's balance. So let's copy this, move it into LND. And you see this looks very, very similar to our other function above. We're just getting the correct endpoint for your channel balances, and we're simply returning that data. But one thing different on the app side here, we can still copy all of this. One thing different on the app side here is that we're going to have to expand some logic here to have polling for balances. So let's look at what we changed. We have get info and get balances is now being imported. We have state set aside for our balances, which is our balance and then the inbound. And then we have a new function right here for fetching balances. And that sets our Lightning balance to the local balance of our channels, which is what we control. And then it sets the inbound to the remote balance, which is what our channel peers control. So like, you know, the inbound that we can receive from the Lightning node versus the balance that we control. And what we updated here as well is in this use effect, we now have a poll interval to every 5 seconds fetch the balances. So we make sure that we have somewhat up-to-date balances. So this runs every 5 seconds. We also call it initially, and then we clean up the interval as well. And then besides that, we just simply drop in this new block of UI that says if we have Lightning balance and inbound, we simply show them on the page. So let's ensure this works. Yep, here we go. We've got Lightning balance with our balance of, what is that, 4,400,000 sats, and then inbound of about 2 million. So that's a pretty good Lightning node setup. Okay, onward. So now we're going to create invoices. We're pulling in the static information. Let's actually take some actions on our node. So here's our create invoice function, which will go in LND right here. So I'll paste that in. This is very similar to our other functions, but this time we're doing lnd.post, posting to v1 invoices, and we actually have some data we're passing here now. This data is an amount for the amount of the invoice we are creating. We then console log the response and return the data. That's great. So now we can go bring this into the UI. Here's where the code starts to get broken up. It gets a little bit too long to hold into one slide. So I'm just going to grab this top bit right here and paste over in app. Just this top bit with app and the states. Great. And then we have create invoice. Yeah, make sure that we're importing create invoice here. Okay, and then we have a handle create invoice function inside of the app. I'll just drop it right here below fetch balances. Great. That will call create invoice from liblnd and pass in an invoice amount that we set in the state. And then finally, we'll get some more UI to drop here into the body. Scroll down to the body, and we'll just put it here at the bottom. Nope, don't auto-populate that. I'm just pasting. Great. And so this new body that we added, let me format. Okay, cool. This new body that we dropped here, it basically says if we have info, meaning if we are connected to our node, then we show create invoice, and there's a number input, and then just a button that calls the handler to create an invoice. And then once that invoice is returned to us, we show it. We show the payment request, which is basically, yeah, just a Bolt 11 invoice. So let's see if that works, and then let's get Mutiny Faucet to pay it for us. So back into the app, we see our new create invoice UI here. So I'll say 21, create invoice, and then our payment request drops below. That's beautiful. Let me open up the inspector here just to show in the console. We also have responses from our node with all of the data here. This is a returned data. This is everything from the API data. So that's awesome. So I copied this invoice. Let's take it over the MutinyNet faucet now to pay it. Let's actually check our balance first. Our balance is 009 at the end. So let's see that change. Strike me now. Okay, it says it's paid. 009. This should update in a second. 030. Boom, there we go. We got our 21 sats. So that's awesome. We can create real invoices and we can actually receive the money. That's pretty useful. Okay, let's push on to the final feature here for sending. Add a method for paying an invoice from API and lnd.js. So this is our pay invoice function that will go in lnd.js. Put it all the way at the bottom here. So this one, once again, is a post request going to channels and transactions endpoint. And we pass in the invoice that we want to pay. And we also have this object here, which is basically setting a fee limit because you pay fees to, route through the Lightning Network. We're setting a fee limit here just because it's a good practice to prevent yourself from getting fee sniped or fee siphoned, which is an attack that's somewhat common on Lightning. So yeah, just be sure to always set a max limit. This shouldn't be needed on MutinyNet, but hey, it's a good practice. Maybe I'll save you some money in the future. So there we go. We send that data over and we should get a response back telling us if the payment was successful or what happened with it. And then finally, we need to bring in the last bit of stuff into app.jsx. So I'll copy this full top bit right here. Go into app. Go all the way down here and paste that in. Beautiful. Next, we'll have the handler for paying invoice. So I'll copy that handler function. And I'll put it right here. Okay, and this handler just sends the payment request to pay it, and then it just grabs the response. If we have the payment pre-image, we know it's successful, so then we set a success message. Otherwise, we set a failure message, and we try and return that error. Great, and then the final piece here will be the UI. And the UI will go at the bottom right here. Okay, great. And let's just format this again. Okay, awesome. So this says if we have info, meaning we're connected to the node, you show the pay invoice title with a text input allowing you to put an amount. And then you have a pay invoice button right here that you click to attempt the payment. And then you'll get a payment response. Some kind of payment response or success or an error. So let's give it a try. So first we'll go to this Lightning address for MutinyNet. We'll go to here again. We'll create an amount equals 21,000 for a 21 sat invoice. We'll paste it into our new form here. Click pay invoice and it works. Payment successful. Here's the pre-image. Beautiful. And then if we try and pay it again, error, invoice is already paid, so that's excellent. It shows us that error as well. We can still create new invoices ourselves as well. So amazing, beautiful. What time are we at here? Okay, we're over 20 minutes. Damn it. That's okay though. I think we're at the end. Let's go in here. Okay, test our Lightning wallet. Okay, we basically did this already. This is like the test process if you're following at home. Verify the alias and the pub key at the top. Verify the balance in the inbound. From our balances, we create an invoice, have MutinyNet faucet pay it. We did that successfully. And then we grabbed an invoice from their Lightning address and we paid that ourselves. So beautiful. That all worked out. And then ours actually looks better. Vite, I guess, has updated and has like a default theme here. But this is how my original one looked when I built it. Ours looks a little bit nicer, more centered. But nonetheless, here you are. This is your launching off spot for building a Lightning wallet. You've got the node set up now. You've got MutinyNet and the tools around it. And then you have a very basic, fundamental working Lightning wallet here that you can go and style, make your own, add features to, and just use as reference and learning opportunity as you continue building on Lightning. So very cool Lightning round workshop here. Thank you for participating and attending. Once again, if you don't know, I created PlebDevs.com. It is a platform where you can learn how to build on Bitcoin, on Lightning, on Nostr. This is just one of many pieces of content that we have covering all manner of topics in Bitcoin and Lightning and all manner of projects. So check out PlebDevs.com. Reach out to me if you have questions on anything covered here, or just to show me what you've built. I would love to see that, especially if you add your own styling and added additional features onto it. So very cool. I'm going to get on with my day now, but I hope this was valuable for you, and I will see you next time. Cheers.